Okay, so slightly more complicated. We're going to look at what happens when we have more than one curve. So when we start putting curves together, what we need to start considering is whether we're having two areas that needed to be added together, or whether we're taking away the area of a curve below another one from the top. Okay, so again, you need to draw your picture. All right, so if we look at example 1, we want to find the area enclosed between the curves y equals x squared, y equals x minus 2 all squared, and the x-axis. So you can see the two curves there. Y equals x squared goes through the origin. Y equals x minus 2 all squared, well, that touches at the point 2. So the area enclosed in between them is this part here. So the way I would do this one is to say, well, until the two curves meet, we're looking at the area underneath y equals x squared, and then from the point where they meet up to the point 2, we're looking at the area below y equals x minus 2 all squared. So what you want to do is actually dissect this up into area 1 and area 2 like this. Okay, so your first step in this is to figure out, well, where do they meet? So how do I do that? Well, that's pretty easy. You just solve simultaneously. So y equals x squared, but that also equals x minus 2 all squared. So when you expand that out, you get x squared minus 4x plus 4. So therefore 0 is equal to minus 4x plus 4, and so x must be equal to 1, which makes sense. It's halfway between the two because they're similar curves. So they meet at this point x is equal to 1. So my first integral to work out area 1 is pretty easy. It's the integral from 0 to 1 of x squared dx. Well, hopefully by now we're all pretty comfortable working this one out. Integral of x squared is x3 over 3, sorry, x cubed over 3 from 0 to 1, which means we end up with a third. Then we need to look at the second area. Now, logic tells us the curves are the same, we've just shifted it. The area is going to be the same. But, just in case our logic skills aren't up to scratch, let's have a go. So area 2 is the integral from 1 to 2 of, now in this case we're integrating x minus 2 all squared. Okay, so then we end up with x minus 2 all cubed all over 3, and we're going from 2 to 1. So if I substitute in 2, I end up with 0. If I substitute in 1, I end up with negative a third. So this is also equal to 1/3. So the area enclosed is equal to 2/3 of a square unit. Okay, now some you're going to add, some you're going to subtract. So have a look at this example here. We want the area enclosed by y is equal to x minus 2 all squared, so that same parabola, and the line y is equal to x. So if you have a look at that graph, you can see what's happening. We've got these two curves and we want the area in between them. So generally you would be saying, well, the area below the line y is equal to x is that whole part there. But I don't want all of that. I'm not including this part here and this part here, which are the parts below x minus 2 all squared. So what we do is we do the top one, and whatever the function is on the top, that's why you need the diagram. You do the top one, so that big area, and then you minus the bottom one. You minus the area below them, and that gives you the area in between. So first step, you've still got to find your points of intersection. So you need to equate them. X is equal to x minus 2 all squared. So x minus 2 all squared becomes x squared minus 4x plus 4. So then 0 is equal to x squared minus 5x plus 4. And when you factorize that, this one factorizes rather nicely. And if you're falling behind in your factorizing and you're getting stuck on that, go back, watch the videos and review those exercises from the beginning of year 11. You need to be able to do that in order to differentiate and integrate efficiently. So your factors here are going to be minus 4 and minus 1, because that's how you get the minus 5x. So x has to be equal to 1 or 4. Okay, which again, it makes sense, doesn't it? Because we know that it touches at the point 2. So 1 and 4 fit in our diagram as well. So to work out this integral, what I need to do is say, well, it's the integral from 1 to 4, because that's where we're going from. It intersects at 1 and then it intersects again at 4. And it is of the top curve, which in this case is x, minus the bottom curve, which in this case is x minus 2 all squared. So I would then expand that. It depends what your function is, but in this one I would expand it because that's going to be easy to expand and then to integrate. So from 1 to 4, we end up with x minus, so it's x squared. Now generally you would have minus 4x, but we're subtracting it, so that's going to become plus 4x, and then it's going to be minus 4. Alright, simplify that before you start integrating. So from 1 to 4 of negative x squared plus 5x minus 4. Now we can integrate. Everything's written as a nice simple power. So that becomes negative x cubed over 3 plus 5x squared over 2 minus 4x. And we're going from 1 to 4. Now once you substitute those numbers in, you work out your answer, you're going to end up with 4.5. So the area, is 4.5 square units. Now the beauty of this method is if one of our curves falls below the axis, your integral will automatically take that into account. You don't need to start separating them. And to show you that it does work, what we're going to do is take those same two curves. So we've got y is equal to x, and we've got y is equal to x minus 2 all squared. And we're going to shift both of them down 2 units. Okay? So it looks like this. So if I take the line y equals x, I shift it down 2 units, it becomes y equals x minus 2. And x minus 2 all squared, you can expand it out and check it yourself, but if I shift it down 2 units, we end up with x squared minus 4x plus 2. So this area is the same as this area. Same curves, same area in between them. We've just moved it. Okay? Let's go through the same process again. So to find your point of intersection, and you can shorten it to POI, we equate them. So x minus 2 is equal to x squared minus 4x plus 2. So we already have it expanded, that's fine. Bring it all over, we end up with 0 is x squared minus 5x plus 4. So that factorizes to x minus 4, x minus 1. See how the process is the same? And so therefore x equals 1 or 4. Okay, so we've still got the same point of intersection because we've just moved it down, and the same thing would happen if we moved it up. we moved it left or right, your intersection would change, but the distance between them is still going to be the same. Okay, so then we need to integrate them. So we are integrating from 1 to 4, and we do the top one, so x minus 2, and then we subtract the bottom one, x squared minus 4x plus 2. And that whole thing is being integrated with respect to x. So we need to put our dx. So what is that equal to? Well, that is the integral from 1 to 4 of minus x squared plus 5x minus 4. Which is exactly what we got for the last one. Same integral. Okay, so your integral takes into account the fact that if it's shifted up or down, we're finding the area. It doesn't matter whether it's above or below, the area is the same. Okay, so your answer here is going to be exactly the same. You're still going to get 4.5 units squared. Okay, so that's what you need to have a go at exercise 3.8. Good luck, and I'll see you in class.